In this example, we have a U-shaped fluid container. In this fluid container, there is water, as you can see in this part of the fluid container. And on top of the water, it seems that there is another fluid, some sort of a liquid with a density that is less than water, since it is floating on top of it. It's not sinking. So I'm gonna make this is some kind of like an oil. So we know from this that the density of this oil must be less than the density of water. Okay, given that water density is 1,000 kilograms per meter cube, we need to find the density here. So this density here is unknown, the density of the oil. Okay, well, how do we go about doing that? Okay, we have to think. Remember, we have a general equation for this one. Our general equation dictates that P2 is equal to P1 plus rho GH. Okay, where is P1 in here? P1 is the atmospheric pressure. So we have this, since this system is open, so this is P1, and this is open also. This is P1, it's open to the air. As you can see, the pressure coming from air on both ends are equal, so it's not going to matter too much. Okay, now how do we go about solving this problem? We need to find the density of this one. Notice that at this level here, the pressure, this guy here, I'm going to call it P2, and a pressure here also, I'm going to call it P2, since P2, it's the same level, so the pressure here should be equal. So this guy and this guy on both levels should be equal. Okay, now I'm going to use this part here. So this equation here is going to be equal to P2, which is equal to P1 plus rho, that's the density of this whole column, all of it here, which is density of water. Now times GH. Okay, what is H here? It's this H we're looking for. Okay, H here is equal to 11 centimeters minus 7. If you notice that, this H here is equal to 11 minus 7. So 11 minus 7 is 4 centimeters. So I'm going to put it 0.04. Okay. Now P2 here is equal to P1 plus the density of what? Of the oil, the unknown oil, times the gravity, and times h, which is the height of the oil, which is 0.07 meters. Okay. Now these two are equal. If they are equal, then subtract P1 from both sides. Okay, so the equation ends up to be rho W times G times 0.04 is equal to rho oil times G times 0.07. Now divide by GG. Okay, rho of the water is given here is 1,000. So plug in the number. The only unknown is the density of the oil, and if you do some calculations, you will find that the density of the oil is equal to 571.4 kilograms per meters cube. And that's it for this one. Thanks.